Hey folks, let's redo problem number 1 with a calculator. So everything starts out the same. Let's see, the coin's supposed to be a fair coin, 50-50. So what's the HO? P should equal 0.50. Do we think it's coming up more or less or different? We think it's less. Okay, so P is less than 0.50. See how those numbers always stay the same? Everything stays the same. The only thing different is the symbol. So basically, you just need to remember that the alternative hypothesis, H1, is either a less than symbol, a greater than symbol, or a does not equal symbol. The null is just usually always an equal symbol. Okay, our test stat, well, go back in time. Our test stat was this big, ugly formula, that crazy thing. You see how it's a Z? And there's one proportion, and it's a hypothesis test. So we are going to be using on our calculator the one proportion, and it was a Z, and it's a hypothesis test. The one proportion Z hypothesis test, one prop Z test. Okay, so I'll go to my calculator. Let's see, calculadora, turn it on, clear. So my tests are under stat, so go to stat, slide over to tests, and I'm going to slide down until I see one prop Z test. One purport. There's a lot of things, two sample T, Z, T, one prop Z test. Okay, enter. It says P naught. Okay, so what's our P in the H naught? 0.50. Okay, so hit clear, 0.50. Then they want the X and the N. Didn't we say before when we read the problem, N was 1,000? We made our friend flip it 1,000 times, and we're interested in 460. So just 460. Whoops. 460 was the X. We also use that in the formula over here, remember? The X over N. So X is 460. The N, clear, 1,000. And then it says our alternative hypothesis. What symbol do we need to give it? A does not equal symbol, a less than symbol, or a greater than symbol? You see how we have a less than symbol? Okay, slide over to less than, hit enter, so it's blinking. Slide down to calculate, and hit enter. Okay, so then it gives me all the information. It gives me my test stat, my Z. Can't really see what's going on. The Z right there. So let me slide this over a little bit. Z, negative 2.53. Negative 2.5298. I'll just call it negative 2.53. And then a p-value of 0.0057. 0.0057. Oh, those numbers look familiar. Why did you make me do it the long way? Trust me, you're going to need to do it the long way with different problems later on. So it's just good to do it with something easy that makes sense. Okay. Okay, so my p-val. Can we see that okay? So then now we're back on the same game. How is that p-val compared to my alpha? The alpha is 0.05. 0057 is less than alpha. If p-val less than alpha, we say reject HO. And if we say reject HO, then we say evidence suggests. Evidence suggests the H1, the alternative. So let's just put that into words like we did before. So evidence suggests, and then I'm just going to copy what I wrote before. Evidence suggests the coin comes up, tails less than 50%. Come on, 50% of the time. Oh, dang. So that was actually pretty fast using a calculator. So notice we quickly got the test stat using our calculator and the p-val using our calculator, and then we had to know what to do with that p-val. Remember, if p-val less than alpha, reject HO. Otherwise, do not reject HO. Okay? So the 0057 was less than the 05. We'd reject HO. If you reject HO, then evidence suggests the alternative. And just put that into words. The proportion is less than 50%. Evidence suggests the coin comes up tails less than 50% of the time. Okay, so now we just did the p-value approach with the calculator. Okay, so let's do the problem one more time using the classical approach, which you're going to find super annoying, but just watch it, because the book keeps asking questions about the classical approach, so watch the next video to understand how to do the classical approach. But yes, calculator way better. Okay.